What up, nerds? We are checking out linear regression today, trying to get your calculator to build some equations for scatter plots and such for you, so you don't have to do as much mental gymnastics. It's 210, so let's try this out on your fancy note taker. What I'd like you to do is take this data, it should be also sitting on your sheet, and this is points scored versus minutes played in the game. So maybe you're playing, I don't know, underwater hockey or whatever. This is the minutes played X and the points scored Y, right? You'd expect that as this one increases, like the longer you play, the more minutes that are scored in the game. That's sort of what I'd expect. What I'd like you to do, we're eventually going to get your calculator to do this, but I'd like you to plot all these points as best you can. I know some of them aren't on the line. Plot them on your graph, and then unpause me. Go. All right, so this is the X, this is the Y. You'd expect this to be independent and the Y to be dependent, right? This depends on the minutes played. So if you graph these, this first one would be 28, 16. So 28, almost 30, and 16. So I think it'd be like right there. Right. This next one would be 35 minutes played and 13 minutes scored. So 35 right on the dot and 13, so somewhere around there, right? And you'd keep doing those for all these X, Y, X, Y, X, Y, right? And you'd get this. Cool. What we want to do today is be able to make a line of best fit, right, that runs through these and find the equation for this. So now that we have all these dots, the line of best fit has to go through two of them, and as best you can is closely approximate the data. So if you picked these 2 points, that might be too, like this point and this point, that might be too high. Or if you picked this point and this point, that might be too low. It doesn't really approximate it. So we kind of have to eyeball and say, hey, let's choose, I don't know, this point and that point, maybe that point and that point. Cool. To make things a little easier, why don't we do this? I'd like you to use these points, 20, 10 and 40, 25. They are in here closely. I'd like you to try using those just to make the numbers easy. Okay, so take these and make an equation that says y equals some slope x plus some intercept. You're going to have to find this and this. I'll show you how to do that in a second, but pause me and try to do it yourself. Go. Okay, so here we go. We were going to use the points 2010 and 40, 25. Now, they should be in here, right? 40, 25 is close, right? I mean, you should use one of these points, but just for simplicity's sake, let's use these because I think it'll be easier for us. We want to use y equals mx plus c. M is their slope, so we have to look at rise over run. Our rise is the change between the y values. So to go from 20, 10, that point, to 40, 25, we have to go up 15, right? It's the difference between here to here. So the rise is 15, and then the run is how far over we have to go on the x from 20 to 40. So that's this piece, right? So that's 20. So this should be 15 over 20, and that's our slope, and that simplifies to 3/4. So far, so good. So we have y equals 3/4 x plus c. All we need to do is find that c coordinate, and that's where this thing comes down and hits the y axis. Now it looks like it's going to be negative. I can't tell where it is because I'm drawing with a mouse, but we can find that point exactly if we take either of our x and y's and plug it in. All right, this should be not new stuff. Here's an x, here's a y. Let's plug in this y for this y, and this x for this x, and then the only thing we don't know is 3/4. The only thing we don't know is c. When you multiply fractions, you go, this is 3/4 times 20 over 1, right? That's this whole piece, plus c at the end. This is 3 times 20 is 60, over 4 times 1 is 4. 10 still sitting here. 60 divided by 4 is 15, plus c. So then to get rid of this 15, we subtract 15 from here, subtract 15 from here. These cancel, and you're left with c is 10 minus 15 is -5, which is sort of what we thought. And so our equation is, our final equation is 3/4 x, right? It's this, and we figured out the c, so -5. That's the equation. There's got to be a better way, and there is. So I assume that you can do that. I assume that that's tedious and kind of ridiculous, but I assume that you can do this. If you can't, I'm going to ask you to do it by hand. If you can't, come get some help, because it's a required skill. But we're going to get our calculators to do it for you. So before we do anything, what I'd like you to do is turn on your calculator, ping, and I want you to turn diagnostics on it. So here's the I'll put the calculator into, there it is, into here. So to turn diagnostics on, I'll tell you what that is in a second, but I want you to hit the second 0. We want it to go to the catalog, so second 0. So you can see what I've just hit right here if you need. And we're going to go down until it says diagnostic on. I think you can do a whole bunch. You can hit alpha D if you want, but I'm just going to go down, 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 down until you see diagnostic on. There's diagnostic on right here, and then hit enter. It says, do you really want diagnostic on? And you say yes, and hit it again. See, I hit enter twice, and it says done. Cool. So that's going to set us up to give us a piece called correlation coefficient that we want in a second. You're only going to have to do this like once when you replace the batteries. So it's done. You don't have to do that anymore. Once that happens, clear it and forget about it. Cool. All right. So now we're ready to go. Let me give you a little brief intro. So this is Australopithecus afarensis, basically like pre-human caveman, like not really caveman, an interesting pre-hybrid to the split between Homo sapien and chimpanzee. They're finding a lot of these fossils of them in caves in Africa, and the evolutionary biology is just exploding because of their finds. It's really interesting. So this is they're doing some things with the lengths of the bones they find and in relation to how tall these things were, and we'll get to that in a second. But you'd expect like the longer the, let's say the femur, right? If you find a longer femur, you get proportionally a taller Australopithecus afarensis, right? If you find a shorter femur, you'd expect a correspondingly shorter Australopithecus afarensis, right? Right, smaller femur means smaller length, as you'd expect. This is a correlation, and the correlation coefficient, this should have correlation coefficient, describes the strength and direction, of the trend line. So let me give you some examples. If all of this is kind of the scatter plot you'd expect, dot, 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 and if you make a line through it, it sort of closely resembles that. If you're, so this has like a 0.8, means pretty close. If you have a 100%, correlation, it means that all of the dots lie on the line. That doesn't always happen, right? Well, that doesn't always happen. So sometimes it's less than perfect, and that's like, I think of it sort of like as 80% of the dots lie on the line. It doesn't mean that, but that's kind of in my head. this sort of means 100% of the dots. This means, in my head, sort of like 50%. It just is how loosely scattered are they, right? This, maybe maybe it's scattered well, or maybe it would look like this. I can't really tell, so it has a low coefficient. They can also be negative, right? So this can also go downhill, like this. And it can be perfectly lined up, but going downhill, like as one thing increases, the other decreases. I'll give you an example of that in a second. Or maybe it's a little looser, right? This is still 0.8, but it's negative because it's going downhill as you read from left to right. This is negative 0.5. It's going downhill, but it's more scattered. This is really scattered, but still going downhill. Something that might have this correlation is like maybe your shoe size versus your height, right? The larger foot size means that the bigger the individual, the taller the height. It's not perfect, but you'd expect as the person gets taller, their foot size increases, right? This might be something like time versus the amount of food in your stomach, right, after breakfast. So right after breakfast, you start with a lot of food in your stomach, and as time goes on, it goes down, 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 something like that. Or maybe like fuel in a gas tank. As you drive, the amount of fuel decreases. Okay. This number is a big, ugly calculation, and we're going to get our calculators to do it. And that's what the correlation coefficient, it's called the R value that we just turned on, is going to do for us. So let's get crack-a-lackin'. Okay, so here's data for the femur length, the leg bone length, and height. And instead of graphing this by hand, what we're going to do is plot it into our calculators. And we have to ask it, we're going to put it in the statistics list. And that is right here. Okay, so you're going to go, I want to do something with statistics. It's this button, right? So you get this set up. I want to edit the list. So you can click up or down until you see the cursor on edit and then hit enter. And then it gives you this blank box. So in this space, this L1 is going to be where you put your X's, and L2 is going to be where you put your Y's. So let me move this over so we can see it. And I'm going to put in, basically complete this table. So I'm going to go 36, enter, 32, enter, 29, 35. You can pause me and fast forward if you need to do the same thing. 30, 27, enter. To get the other list, go over and then go 160, 143, 187, yada, yada, yada. 61, 64, 140, and 131. You should have blank and blank at the bottom. If you don't, you've mismatched somehow. Great, so now we've got our data in there, right? And what we want to do with that is we want this to give us the equation. Let me clear all this now. Clear. We want this to give us the equation, so we're going to ask it nicely by going back to statistics, right? Go back to stats, and then going to calc. So we have to go over to, we want it to calculate the statistics now. So go over to calc, and we want it to calculate a linear regression for us. Regression is just an equation. Linear means line, right? So we're going to go down, or you can just hit 4 and then hit enter. And it gives you this. It says X list. Yeah, we put all our X's in L1, so go down. Yeah. Y list. Yeah, we put all our Y's in L2. These are for a little bit more fussy things, so go down, down, down until it says calculate. It should blink on calculate and say, yeah, go. And it gives us this, and it spits out this mess for us. Notice that you have this R squared and R value. If you don't, you didn't do the diagnostic on. This diagnostic on turns this R and R squared, or otherwise you don't see it. So back here, right? Once you do that, you should see this screen face. And and then your calculator's job is done. Flippin' sweet, right? What this did for us is gives us a couple of things. It says, here's my equation style, y equals ax plus b. It gives us the a value, right there. It says the a value is 2.91. Sure. So y equals 2.91 x plus, and then it also gives us our b value, this piece, 54, right? Use your best judgment when you're rounding. Plus 54, and there's our equation, right? So y equals 2.91 x plus 54. So that's the equation that describes this data, right? And if you were to plot this data on a graph, oh, this is the visual of how to do that. If you were to plot this on a graph, here's your dots, and here's the line, like that, right? So that should be your equation. We got it from this, and this R value tells us, is the correlation coefficient, and tells us that it's strong because it's close to 1, right? It's close to 1.0. Anything between like 0.8 and 1.0 is strong correlation coefficient. It means it's good. And positive just means as you read from left to right, it goes uphill. As the leg bone length, the femur length increases, the height increases, which is what you'd expect. Yeah, great. So we've got our equation. Bam, it's there. We're done. Right. What I'd like you to try is take the same, do the same thing with different data. Okay. So I'd like you to figure out. This is talking about like horsepower in cars. It means engine size, engine power, and the gas mileage. You'd expect like a bigger engine is going to be less efficient with gas, right? And a smaller engine is going to be better with gas. So what I'd like you to do in a second is plug these in. Let's use X as horsepower and Y for gas mileage, because I think this one depends on this one. You're going to plug them into your calculator, and you're going to get an equation and a correlation coefficient. Let me show you how to do that, and I'll to clear your screen, and then you plug it in. Okay, so yeah, we want to clear. We're going to clear like this. Hit this button to clear it. But if you go back to Stats and Edit, we still have all of our data in there. So you have to go up into L2, hit Clear, go down, go over, go up into L1, clear, right? Go down. It doesn't work to go over. You have to go down and then it clears. So you're going to put your data back in here. I'll do it real fast. 175, 255. Oops. I'm in L1, sorry. So I have to go down to here, and then I can go 175, enter. 255, enter. 140, enter. 165, enter. 115, 120, 190, 180, and 110, and 125. And then in the other column, the Y column, hit over. Go 22, 13, 25, 18, 32, 28, 15, 21, 35, 30. Great. We've got all our data. Go back to statistics. We say we don't want to edit it anymore. We go over to calculate and go down to linear regression, or you can say 4. Right. Yep, we got all those in there. Hit calculate for me. And there's our screen. Right? It should look like this. It should look like this guy. So let's get rid of this. You don't necessarily need the data on the graph. You don't need to plot these points, but you'd expect as the horsepower increases, the gas mileage, the efficiency decreases. So this is the screen you should have gotten. From that, you should write down A x plus B, and the R value is -9.16, right? -0.916, which means it's good approximation of the data. The negative just means as you increase one thing, the other thing decreases. Cool? If you're clever, you can use this equation, to predict the gas mileage of a 280 horsepower engine, right? This is an X value, so plug it into the X there and get a Y value out. Should be about 5.5. Try that out on your homework, and when I see it in class, we'll try a bunch of these and make sure you're comfortable with it. Okay, bye.